Alright guys, here's part 2 of example 7. We found the first root, so now I'll explain it. I've adjusted my little orange lines here to be a little bit closer to 15 degrees. I think they were a little too far out before. But if I have the fourth root of 5 cosine of pi over 12 over cosine 15 plus I sine 15 degrees, what that means is that if I raise that to the fourth power, I will end up with 5 cosine pi over 3 plus I sine pi over 3. And that, right over here, if I take this, that's 60 degrees. So 60 degrees is roughly there, okay? And let's pretend this is a measure of 5. Now, my orange lines are not perfect. I could have sketched this a little better, but hopefully you guys get the idea that if now I have the fourth root of 5, well, you know what? What is the fourth root of 5? So let's just check that out. 5 raised to 5, 1.5. So if Z1 is 15 degrees in that direction at 1.5, then maybe it's somewhere over here. It's going to multiply by itself 4 times, which means the next time it multiplies by itself, it's going to add 15 degrees, and maybe it'll be over here when it multiplies by itself. And it multiplies by itself again for the third time, and then it'll be over there. And hopefully when it multiplies by itself for the fourth time, it'll be over there, which is the complex number 5 cosine pi over 3 I sine pi over 3. So this ideally is Z1. Now, this picture is not really good to look at. If you put it in your notes and you try to sketch all the other ones, it might get confusing. So don't overdo the graphing. Just understand that when you add the angle repeatedly, 15 plus 15 plus 15 plus 15, or just 4 times 15, you end up at 60 degrees, and the radius multiplied by itself 4 times, or raised to the fourth, will get you 5. And that's what Z1 is. How do you get Z2? Well, Z1 was in the direction 15 degrees. Z2 is really easy because you just add 90, and that's going to be Z2 is just, again, fourth root of 5. But you're just going to take that and plus 90 degrees, or pi over 2, right? Because, I told you they're going to be spaced apart by 90 degrees. Now, there are proofs and stuff that show this. There's ways to explain it as well. But in this case, I think the method itself is very intuitive. So I won't muddy that up too much like I do sometimes. So 90 plus 15 would be 105 plus I sine 105. And again, that's it. All right. Z3 would be the fourth root of 5. And then again, you add another 90, or pi over 2. And then it's cosine of 195 plus I sine of 195. And you got a Z1, a Z2, and Z3. And guess what? There's going to be one more Z because it's the fourth root. We expect 4 answers. So Z4 is the fourth root of 5 as its radius, but it's going to be cosine of 295 degrees plus I sine 295. That's really easy. And it's nice because if you take a look, again, don't try to plot this out too much, but this is 105 degrees right over here. If you think about it, this is how big 105 is, right? So if 105 were to, if Z2 were to be raised to the fourth, then it'd be 105 plus 105 plus 105 plus 105, 105 times 4. So it would do this 4 times, right? So 105 would end up like there's another 105, and another 105, and another 105, and another 105, and you end up actually where 60 degrees is. And just to show it, 105 times 4, right? 105 adds itself 4 times. That's 420. Well, 420 is over 360 by how much? 60 degrees. Notice you're in the direction of 60 degrees, and you also do know that the fourth root of 5 times itself 4 times raised to the fourth is 5. And so you end up with that. And the same thing goes with the 195 and the 295. 295 times 4 is going to get you some large number, but if you take away the 360s, you end up with 60. So at the end of the day, this math is relatively easy as long as you know how much each one of the different roots are separated by. So if they ask you for the 10th root, then you take 316 divided by 10, and you know it's 36 degrees that they're apart each. All right, and it's just so easy. The formula is kind of hard to follow because the formula is mixing together that n. So that n is basically saying, hey, actually, you know what? It even looks messy there, so I'll look at this one because I can mark this one up. But if you look at it, that theta is pi over 3. That's the 60 degrees. So what did we start with? We started with 15, right? Well, the reason why it's 15 is because it's theta over n. So that's 60 over n. That's your 15, right? So what's this part? Well, that part is just adding 360 divided by n. But what's the k part? Well, the k part is just so that the formula works in an algorithmic way, which means k is defined as starting at 0 and going to n minus 1. Well, if you take a look at our first z, our first root, we didn't add anything. We just divided the starting theta with pi over 3, divided it by 4. We got 15 degrees or pi over 12. We didn't add anything, and that's why it says plus 2k over n. The 2 pi over n part is the whole 90 degrees. It's the 360 divided by 4 because there are 4 roots. The k for the first answer is 0. So you don't add anything. It's just theta over n, 60 over 4, or 15 degrees. It's 2 pi times 0, or 2 pi over n times 0. So that part, you don't add the 90. That's why this first answer had an angle 15. But once you get to the second answer, that k becomes 1, and then you have to add the 90. And then the following one, you add 2 90s. Think about it. If I add 90 here, and then I add another 90, that means by the third root, I'm adding 180, or 2 times 90. By the fourth root, I'm adding 3 90s, or 270. And that's what k is. K is saying how many of the separating angle spaces am I going to add by. And if you look at their work in the textbook, notice over here, 2 pi over 4, they add 0 of it. And then over here, notice they want to do pi over 2. That's your 90 times k, right? They want to add that part. And in the first root, they add none of that. But in the second one, they add a single 90. And in the third one, they add 2 90s, or 2 pi's over 2. And then in the fourth root, they add 3 pi over 2's, right? And so that's how this formula works. And it's an easy formula to use too. But if you just look at it from how we did it, you get that first angle. And that first angle is it makes a lot of common sense, right? If you want something to multiply by itself 4 times, if you want to add something 4 times or multiply by 4 to get your 60 degrees, it's just going to be 60 divided by 4 to get you 15. And to get every subsequent one, just keep adding the separating space in between your roots. And that's it. So hopefully example 7 makes a lot of sense.